Hi guys, and today we're still focusing on our Cambridge Nature Science interview exam, and today we have the problem of 101. A light in elastic thread is stretched around one half of the circumference of a fixed cylinder, as shown in the figure, and as a result of friction, the thread does not slip on the cylinder when the magnitudes of the force acting on its sides fulfill the inequality, and determine the coefficient of the friction between the thread and the cylinder. So the first thing you need to consider is about the symmetrical one. So if FA is bigger than FB, then FA over FB must be less than a typical constant, so that it does not slip. And so when FA is smaller than FB, FB over FA should also be smaller than something. So these two coefficients must multiply and get a 1 because it is symmetrical, right? So if you calculate some answers that is not symmetrical in the answer, it will definitely be wrong. So you have to check about that. And next, so I'll tell you how to deal with the thread problem, because in these problems the tension of here, it is actually F boy, here FA, they're not the same. So in each spot it does not have a constant tension, so you're not going to deal with it when we are considering like other problems that we did. You can't use something like the pressure method or other things. So next we will focus on this. So assume we are going to figure out the F here, and we have this angle of alpha. So I will denote this F here by F alpha. So we will concentrate on this little part of the circle. So here we have an F of alpha. Here we have F alpha plus delta alpha, right? So this is delta alpha and this is alpha. So the total force is what? The total force would be very easy, and you must have known that it points to the center, and it equals to N equals to 2 this, and it approximately equals to F delta alpha. So what is this thing? It is in equilibrium with the frictional force. So delta F equals to mu times N, right? So now we have delta F alpha equals mu times F alpha delta alpha. And don't you think that this is very similar to the equation? And we will use derivative to reconsider this equation. dF equals to mu times F times d alpha. So dF over F equals to mu d alpha, and we can know by ln F equals to E to mu alpha. F equal, you are going to calculate about the constants, right? So we have F alpha equals to F0 times E mu alpha, where F0 actually we can find it is a smaller one. So when I'll take this one. So actually we're just going to figure out F pi over F0, that equals to F2, right? So we're going to calculate the mu. It equals to ln 2 over pi, so 0.22. This is not very hard when you figure out how to calculate about the relationship between the frictional force and the tension in the thread. So one more thing for you. You must have known about the equation F equals to mu times V squared. It is actually when it is not in contact with any other body, but in this problem it is in contact with the fixed cylinder, so you can't use this formula. And it is not moving, so you can't use the moving thread formula, right? So this is wrong actually. So I hope to see you next time and hope everything goes well.